Hi guys, this is Vinavi George from RVGMATHS and Talents. Welcome all of you. Today we are studying Polynomials Part 5. Relationship between zeros and coefficients of a polynomial. Let us start. Consider a linear polynomial p of x equal to 2x plus 3. Here the degree is 1, so this is a linear polynomial. We have already studied this, is it? We want to find out the zero of this polynomial. Let k be the zero of this polynomial. Then we know that p of k equal to 0. That means instead of this x, we can substitute k. Then we get 2k plus 3 equal to 0. That means 2k equal to negative 3. That means k equal to negative 3 upon 2. That means negative 3 upon 2 is the zero of this polynomial. And we know 2x plus 3 is the polynomial. Here 3 is the constant term and 2 is the coefficient of x. Then we can relate the zero of this polynomial and the coefficients like that. Zero of the polynomial is minus 3 upon 2. That means minus of constant term upon coefficient of x. Is it? So we got a relation between zero of the polynomial and the coefficients of the polynomial. We can generalize this. See, the zero of this polynomial p of x equal to ax plus b is k. Then we get p of k equal to 0. That means ak plus b equal to 0. That means ak equal to negative b. That means k is negative b upon a. That means zero of the polynomial is negative b upon a. And we know ax plus b is the polynomial. That means negative b means negative of constant term upon coefficient of x, that is a. Are you following? That means we got the relation here. Zero of the polynomial is negative constant term upon coefficient of x. That means negative b upon a. Then consider quadratic polynomial p of x equal to 2x square minus 8x plus 6. Here we want to find out the zero of this polynomial. We are finding the zero of this polynomial by the method of splitting the middle term. Middle term is minus 8x. Here we split like this. Sum of these terms should be middle term, negative 8x, and the product should be product of these two terms, that is 2x square and 6. That means 12x square. So we want minus 8x as the sum and product as 12x square. So for that we are finding the factors of this 12x square. We consider the factors of 12 as 1 and 12, 2 and 6 and 3 and 4. From this we want to find out two terms such that the sum should be minus 8. That means we can select here 6 and 2. And the product should be 12x square. That means we can take these terms as negative 6x and negative 2x. Then the sum will be negative 8x and this product will be 12x square. So we can split like this: 2x square minus 6x minus 2x plus 6. Okay. If we take these two terms together, we can see 2x is common here. So if you take 2x outside, then 2x times x minus 3. Then if you consider these minus 2x and 6, we can see minus 2 is common here. So we can take it outside, minus 2 times x minus 3. So we can, if you consider this, x minus 3 is common here, then we can take it outside, then we will get 2x minus 2 times x minus 3. Okay. Here again you can see 2 is common here, so 2 is taken outside, we get 2 times x minus 1 times x minus 3. Okay. That means 2x square minus 8x plus 6 can be written like this: 2 times x minus 1 times x minus 3. Then we want to find the 0 of this. So this is equal to 0 means here you can see 2 cannot be equal to 0. So x minus 1 can be 0 or x minus 3 can be 0. If x minus 1 equal to 0, we will get x equal to 1. Here if x minus 3 equal to 0, we get x equal to 3. That means 1 and 3 are the zeros of this polynomial 2x square minus 8x plus 6. Okay. So here we can see sum of the zeros is 1 plus 3, that is equal to 4. And 4 equal to 8 upon 2. And observing the coefficients here, we can see minus 8 is the coefficient of x and 2 is the coefficient of x square. If we relate this, we can write this 8 upon 2 as negative of negative 8 upon 2. That means negative of coefficient of x upon coefficient of x square. That means we are getting a relation here. Sum of the zeros is equal to negative of coefficient of x upon coefficient of x square. Okay. Then product of the zeros is 1 times 3, that is equal to 6 upon 2. And this 6 is the constant term. So we can relate like this. Product of the zeros equal to constant term upon coefficient of x square. Okay. So we got the relation between zeros and coefficient of polynomial. Okay. Consider another quadratic polynomial 3x square plus 5x minus 2. See here also we want to find the 0 of this polynomial. For that we are splitting the midterm. Midterm is 5x here. We can split this as the product of these terms should be 3x square into minus 2. That means minus 6x square. So the product should be minus 6x square and sum should be 5x. For that we are taking the factors of minus 6x square. For that we consider factors of minus 6 are minus 1 and 6 or 1 and minus 6 or 2 and minus 3 or minus 2 and 3. Here we can see we want to find the sum as 5x, the factors as 6 and minus 1. So we can take 6x and minus x. So we can split like this 3x square plus 6x minus x minus 2. We can see 3x is common here. So if you take 3x outside, 3x times x plus 2. Here you can see minus 1 is common. So minus 1 is taken outside. Minus 1 times x plus 2. Here you can see x plus 2 is again common here. So if you take x plus 2 outside, we will get 3x minus 1 times x plus 2. Hence the value of 3x square plus 5x minus 2 is 0 when 3x minus 1 is 0 or x plus 2 is 0. 3x minus 1 equal to 0 means x is 1 by 3. X plus 2 equal to 0 means x is minus 2. So we are getting here 1 by 3 and minus 2 are the zeros of this polynomial. The zeros of this polynomial are 1 upon 3 and minus 2. So sum of the zeros equal to 1 upon 3 plus minus 2, that is equal to minus 5 upon 3. That means the polynomial is this. Then that means here also we are getting negative of coefficient of x upon coefficient of x square. And product of the zeros is 1 by 3 times minus 2, that is minus 2 upon 3, constant term where it is negative 2 upon coefficient of x square, that is 3. So we are getting product of its zeros is equal to constant term upon coefficient of x square. So we got the relation between zeros and the coefficients. So in general, we can say if alpha and beta are the zeros of a quadratic polynomial p of x equal to x square plus bx plus c, where a not equal to 0, general form of a quadratic polynomial, then we are getting sum of zeros alpha plus beta equal to negative b upon a. That means negative of coefficient of x upon coefficient of x square. Product of zeros equal to alpha beta, that is equal to c upon a, that is equal to constant term upon coefficient of x square. Then consider next example. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Here p of x equal to x square plus 7x plus 10. We want to find the zero of this polynomial. For that we have to split the midterm. So we can split like this and continue. X square plus 7x plus 10 equal to x square plus 5x plus 2x plus 10. That is equal to x times, here we are taking x outside, x times x plus 5 plus 2 is common here, 2 times x plus 5. Then x plus 5 is common here. Then x plus 5 is taken outside. You are getting x plus 2 times x plus 5. Then x square plus 7x plus 10 equal to 0 means x plus 2 times x plus 5 equal to 0. Here we can see x plus 2 equal to 0 or x plus 5 equal to 0. That means x equal to minus 2 or x equal to minus 5. That means the zeros are minus 2 and minus 5. Okay. Then we can verify it. Sum of zeros is minus 2 plus minus 5, that is minus 7. And you can write it as minus 7 upon 1, that is equal to negative coefficient of x upon coefficient of x square. Okay. Then product of the zeros is minus 2 times minus 5, that is 10. That is 10 upon 1, that is equal to constant term upon coefficient of x square. Okay. Then come to the next example. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. We can write this x square minus 3 like this. X minus root 3 times x plus root 3. Is it? That means the zeros are x equal to root 3 or x equal to minus root 3. That means zeros are root 3 and minus root 3. Then sum of the zeros is root 3 plus minus root 3, that is equal to 0. That we can see here, negative of coefficient of x, that is equal to 0 here. So 0 upon coefficient of x square is 1 here, 0 upon 1. Is it? That means it is verified. The relation is verified here. Then product of the zeros is root 3 times minus root 3, that is equal to negative 3, that is equal to negative 3 upon 1, and that is equal to constant term upon coefficient of x square. So hence it is also verified. So we have seen the relation between the zeros of a polynomial and coefficients of the polynomial. Okay, I think all of you have understood this. So thank you for watching. Let us see in the next class.